So to do that, we'll introduce this concept of a model. And a model is just a set of probability distributions that encodes certain assumptions. So in our way of thinking about the world, our data are drawn from a data generating process, or if you want to think of like a broader population, or however you want to think about that. But a single data generating process is a probability distribution. Now, we don't know what that is, right? So it could be any one of some number of possibilities. And that's exactly what we're calling a model. So a model is just a set of possible distributions that we enumerate. And in this case, it's finite. There are these three different possibilities. But more generally, we could think a bit more broadly about that. So for example, let's say we have one continuous variable, like blood pressure, and we want to think about like, well, what are the possible models for that? Well, here's a very, very simple, very specific model. I assume that x is drawn from a normal distribution, the standard normal. Now, that's a very small set. It just has one element in it, which is this normal distribution. So I can broaden that a little bit bigger. And I say, well, maybe, so x is drawn from a distribution. And what I know about that distribution is that it's normal, it has a standard deviation of 1, and the mean is somewhere between -1 and 1. So there are a lot of normal distributions that satisfy that, right? Like I could pick mu any of these values, and that would be inside of this model. So it's a set of distributions. And I could now broaden that even further. And I could say, well, okay, now I'm not going to assume the mean is between -1 and 1, but I'm going to say that the mean is any real number. So that's a bigger model. Or I could say the mean is any real number and the standard deviation is any positive number. And now I could even broaden further and say, I'm not even going to assume it's normal. I'm just going to assume it's drawn from some continuous distribution, right? And everywhere here I've been assuming that these are all IID. And now lastly, I could say they're not even IID. They may even be kind of correlated with each other somehow. So these are all like a nested sequence of models. We're just broadening the possibilities that we are considering. And of course, we never really know exactly what this is, but it is just a tool, a conceptual tool that we use to think about what are our assumptions that we're making. So if we have a smaller model, that's fewer possibilities, and we're making more assumptions. So for example here, right, this is a very bold assumption to make, right? Like I'm just telling you that I know what the standard deviation is. That's exactly 1. That's insane, right? But the bigger my model space the bigger my model gets, the fewer assumptions I'm making about what reality actually is. And so larger model is more possibilities, fewer assumptions. So ideally, we're going to be operating in a space in a very large model where I'm not really making any assumptions at all. But we'll kind of see that's sometimes not possible. So let's give some examples. Is it reasonable to assume that birth weight is a continuous random variable? I think that's reasonable, right? Like it's a measurement on a. I mean, even more. I think it's reasonable to assume that it's a positive random variable, right? That much we know for sure. And now let's say, is it reasonable to assume that it's normal? I mean, I think that's maybe questionable, right? Probably not the worst assumption, but don't think it's true, strictly speaking. So I wouldn't want to say that if I really didn't have to, if I weren't backed into a corner. And this third one, that's what I actually already said. Is it reasonable to assume that it's in a given range? I think that's totally reasonable, right? Like, I think that you can definitely lower bound it at 0 pounds, and you can probably upper bound it too. I mean, for sure you can say, like, no baby is going to be born weighing 100 pounds, right? Like, that's not insane to say. You could probably even say 50 pounds. You could probably even get over 25, right? There's maybe some baby somewhere that is enormous, but like for sure you can upper bound it with something, and that's not crazy. So then the last point here is write each of those above as a set of distributions and determine the relationship between each of them. So let's have a look at that. So first we have, say this is all continuous distributions. of 1 RV. And then we were considering normal distributions. So normal distributions is some subset of that. And then what else did we have? The mean in a given range, but not necessarily normal. So normal distributions. So let's say that we want to have a set of bounded distributions. So this is like x is normal, and then here's a set of distributions where x is bounded between some values a and b, like let's say 0 pounds and 100 pounds. What does that look like? Is it going to, clearly that's some subset of all continuous distributions, but my question is it going to intersect with the normal distributions or not? And actually it doesn't. Why is that? Because a normal distribution looks like this, and actually no matter how tight I make it, there actually is always some probability mass in the tail. So it cannot be bounded. No matter where you cut it, there's always a little bit of probability mass outside of that. So it's not strictly bounded like this. So in fact, these are these look like this. What else do I have here? Yeah, so that's it. Those are the sets of distributions, and my argumentation was that I think it's this one is probably reasonable for some values of a and b, and of course you can draw even like tighter, right? So this is like if we bound between 0 and 100, and this one could be like between 0 and 25 pounds, right? You could make that even tighter if you want, but I think that our truth is probably somewhere in here if we're talking about like birth weight, this random variable representing birth weight, and I don't think it's over here and or over there. I think this is a reasonable set of assumptions.